In this video, I want to go over these two questions and try to apply the product to sum or sum to product formula of trigonometric functions to prove these two questions. So let's try the first one now. So in the first question, we have to prove that the given equation is equal to 0. So let's try to apply the transformation formula to each of these components in this equation. So before we do that, let's multiply and divide by 2 so that they are in the format where the formula can be applied. So the first part would be 1 by 2 times 2 sin A times sine of B minus C, and the second part would be 1 by 2 times 2 sin B sine of C minus A, and the last one would be 1 by 2 times 2 sin C sine of A minus B. Now this is of the format 2 times sin A sin B. So here we will apply the formula, which is cos of A minus B minus cos of A plus B. So this is the application in each of the terms. So the first part will be 1 by 2 times cos of A minus B, which is cos of A minus B plus C, minus cos of A plus B, which is A plus B minus C. And now let's apply it to the second part here. That would be 1 by 2 times cos of A minus B, which is cos of B minus C plus A, minus cos of A plus B, which is B plus C minus A. Now the last part would be 1 by 2 times cos of A minus B. In this case it would be C minus A plus B minus cos of C plus A minus B. Okay, now let's look for terms which can be cancelled out. So let me use a different color so that it's easier for us to mark the cancellations. So the first one, A minus B plus C, this is a positive value, so we have a negative value of that here, so we can cancel that out. Then the second is A plus B minus C. So let me use a different color. So A plus B minus C, so that would be, this is a negative value and this is a positive value here. So we can cancel these two. And then the last one is B plus C minus A. This is also B plus C minus A. So these are similar, these two terms. So all the terms in the question gets cancelled out. That's why we'll have the value of the equation as 0. So that is how we can solve the first question. Let's try the second one. So in the second question, we have to prove that this equation will be equal to 0. This is a long equation, so we have to be careful when writing it down. So what I'm going to do is, I'm going to divide this into 3 parts so that it's easier for us to write down the entire equation. So I'm going to consider this as part 1, this is part 2, and this is part 3. So let's address the part 1 first. So this is of format SinA.CosB. So just to apply the formula, what I'm going to do is, I'll multiply this with and divide with 2, multiply and divide by 2. So this is A minus D, correct? So the first part and the second part would have the same thing, 2 sin C minus A times cos of B minus D. And the last part is 1 by 2 times 2 sine of A minus B times cos of C minus D. Okay, now here we can apply the formula of 2 times sin A cos B, which is sine of a plus b plus sine of a minus b. So this is the formula which we are going to apply on all the three parts of this equation. So let's address the first part now. So the first part would change to 1 by 2 times sine of a plus b, which is sine of b minus c plus a minus d, plus sine of a minus b would be b minus c minus a plus d. So this is our part 1. I'm just going to write a plus here. Now I'm going to address the second part, which is 1 by 2 times sine of, again a plus b is c minus a plus b minus d, and the second part would be sine of a minus b, which is c minus a minus b plus d. Write a plus here. Then last part is sine of a minus b plus c minus d plus sine of a minus b minus c plus d. Now for the ease of calculation, what I'll do is I'll write this in alphabetical order so that it's easier for us to look for terms which can be cancelled out. So the first term can be written as a plus b minus c minus d plus sine of minus a plus b minus c plus d. That would be our first term. Then the second term would be 1 by 2 times sine of minus a plus b plus c minus d plus sine of minus a minus b plus c plus d. Okay, then the last term would be sine of a minus b plus c minus d plus sine of a minus b minus c plus d. Okay, now if you observe here, we do not have any term that cancel out each other, correct? But we have an information that sine of minus x is minus sine x. So now we have to find terms which actually have a relationship of x and minus x. So let's consider the first term. Let me change the color so that it's easier for us. So this is our first term, which is a plus b minus c minus d. Now if we consider minus 1 as a common factor, we would get a plus b minus c minus d between these two terms, correct? So this can be basically written as minus 1 times a plus b minus c minus d, correct? So we found the term that cancel out each other for these two, because sine of minus x is minus sine x. So these two terms gets cancelled. Now for the second term, let's look for that. Let's use a different color. So here we have minus a plus b minus c plus d. So to cancel this out, we can use this term. So this can be written as minus 1 into minus a plus b minus c plus d. So sine of minus x is minus sine x. So we can cancel this out, correct? Yes. Now the last term that we have is minus a plus b plus c minus d. So the remaining term is this one. So if we have minus 1 into minus a plus b plus c minus d, if you say this is again a sine of minus x is equal to minus sine x scenario. So we can cancel out these two terms. So now that all the 6 terms are cancelled, the value of our equation would be equal to 0. So this is one of the unique problems that I found out, and I thought I'll share it with you guys. Please share this video with your friends so that it's helpful to them too. And practice as many problems as possible so that you are very well versed with using the concepts of trigonometry. Thank you so much for watching. I'll see you in the next video.